So today I'm going to talk to you about torque. Now, what is torque? Well, torque is a force that tends to cause rotation. Here's a visual. If my left finger is the fixed point and my right hand is the force of my hand is causing the ruler to rotate. Let me show you what I mean. So you have a fixed point on one side and the force that's acting on the ruler on the other side. Well, the difference between the fixed point and the force is called torque. The symbol for torque is a little squiggly T called tau, and the equation for torque is force times distance. So we know that force is measured in newtons and distance is measured in meters. So torque's unit is Newton meters. So let's go back to the example with the ruler. You still have that force that's acting on the ruler, and the force always has to be perpendicular to the distance between the fixed point and the force. It wouldn't really make sense to make the force be parallel because then the ruler wouldn't go anywhere because of that fixed point. If you put that force at an angle, eventually it'll start going parallel. So here's a little side note. Let me draw out the ruler with the fixed point and the force. So when the force is going clockwise, that means the force is going to be negative. When it's going counterclockwise, it's positive. Okay, so let me show you an example. Let's say that force is 5 newtons. And the distance between the fixed point and that force is 10 meters. So you'd apply it to the equation, which is force times distance. So it would be 5 newtons times 10 meters. And that would give you 50 newton meters. So remember that, 50 newton meters. So let's say that there is another force acting on the other side of the ruler, and we don't know what that force is. And remember, since it's going clockwise, it's negative. And that distance is 5 meters. And the ruler isn't moving at all, which means that the torque is 0. So in order for us to find that force, we're going to have to add the 50 newton meters that we got to the torque of the other side, which is 5 meters times the force. So you have 50 newton meters plus the force, and since the force is going clockwise, that means it's negative. And multiply that by the distance, which is 5, equal to 0 since the ruler isn't moving. And now you solve for F.